video we have seen about the parallelogram law, how it works, and how we can say when I am adding these two vectors, the resultant vector will be the diagonal of the parallelogram. And now I am going to do the derivation of those things. So let us consider. So here when I extend these vector and I am just making a perpendicular line from the point to Q, let us mention that as N. So here this triangle, let us consider this thing as triangle. That means from O to Q and from here to here. So here it will be N, here it is O, and this will be Q. So here, so this distance let us consider R, and I don't know, we are going to calculate that. And from here to here there is a point P here, and O to P, it is the distance of, the length will be A, and P to N I don't know. Similarly from N and Q I don't, but as it is perpendicular, we know that it makes an angle 90 degree. From the Pythagoras theorem I can write that R square which is equal to O n square plus n q square, and this can be written as R which is equal to root of this ON. The complete length ON can be written as OP plus PN. So I will be writing it as OP plus PN the whole square plus NQ square. But I don't know, I know the distance OP which is A vector, but I don't know PN and NQ. So to find PN and the distance of NQ, I am just going to consider this small triangle. This one I am going to consider. So that will be, let us redraw that small triangle. Here I am just going to draw it. This will be P, N and Q, and this length, let us see here. As I told you earlier, this side and this side of the parallelogram will be having the same magnitude, B vector and B vector. So this length can be considered as B, and here I don't know N, Q, and P, N I don't know. Now let us see here, if this B vector is making an angle theta with respect to the A vector, similarly here this side also will make an angle theta. So here I can write this angle as theta, and to find the length of PN and NQ, that means the sides, either I can consider the sine theta as well as cos theta. So if I consider sine theta, it will be opposite side by hypotenuse. So opposite side is NQ divided by B, that means PQ. I can write NQ as B sine theta, and similarly cos theta can be represented as adjacent side divided by hypotenuse. So it will be Pn divided by B. So Pn, that can be written as B cos theta. So here now I found NQ as well as PN. So instead of NQ and PN, I am going to substitute it there. So let us rewrite that equation again. R, that will be the square root of, so instead of OP I am going to write A, plus what is PN, I got it as P cos theta square, plus NQ is what it is, B sin theta the square. So what I will get, so this is the formula A plus B the whole square. I am just going to expand it. It will be A square plus 2AB cos theta, plus it will be B square cos square theta, and plus here if I take the square inside, it will be B square sin square theta, which is all under the square root, and that is equal to R. So now see here, B square is common, so I can take that out. So A square plus 2AB cos theta plus B square, which is cos square theta, plus sin square theta, and this will become as 1. So I can write it as A square plus B square plus 2AB cos theta the whole square root. That will be the formula to find the resultant vector vector of the two vectors when I add. That means if I add A vector and B vector, the resultant vector that will be calculated by using this formula, where theta is the angle between the two vectors A vector and B vector. Now let us consider this resultant vector is making an angle beta with respect to the A vector. So I have to find this angle. To find this angle, see, listen here. So in this diagram, I can consider this angle as what? Beta, which means the larger triangle, the OQN is having an angle beta. I want to find that beta. So to find beta, I know this PN distance also now and NQ distance is also now. So I can substitute tan theta. So what is that bigger triangle? So this will be the bigger triangle NQO, and here it is P. So this entire distance will now become as A vector plus PN. What is PN? We found here it is B cos theta. So it will be A plus B cos theta, and this distance we found it as NQ, which is B sin theta. So here I can write it as B sin theta, and this will be the resultant vector which makes an angle beta. So now I can substitute the formula tan beta is equal to opposite side by adjacent side. So it will be B sin theta divided by A plus B cos theta. So now we got the two formulas. One is to find the value of the resultant vector, and there is another formula which can find the angle which the resultant vector makes with the first vector, which is A vector. Suppose if I am considering the angle from the second vector, for example here I am just calculated tan beta. If I want to calculate the angle of this resultant vector between, that means the angle between this resultant vector and the second vector, let us consider that as alpha. So just we need to do a little alteration in the formula, which means tan alpha can be written as A sin theta divided by B plus A cos theta. Just we are swapping the vectors, which means, so I am just redrawing it again. If I consider this as A vector and here it is B vector, and the resultant vector will be the diagonal of the parallelogram of by making the A vector and B vector as the adjacent sides of the parallelogram. And now let us write this theta will be the angle between A vector and B vector, and now this alpha will be the angle between A vector and the resultant vector. Then alpha will be the angle between R vector and B vector. So these were the things we have to keep in mind. If I am calculating B vector, then I have to use this formula. If I am calculating alpha, I can use this formula. Now there are three different cases in this. So if I am having these two vectors, if these two vectors are parallel to each other, if these two vectors are parallel to each other, for example A vector and B vector, then the angle between this A vector and B vector will be 0. So if I substitute in this formula, which is R is equal to square root of A square plus B square plus 2AB cos theta. So instead of theta, if I substitute 0, cos 0 will become as 1. So that will be in the A square plus B square plus 2AB root, right? So it is similar to the formula A plus B the whole square and under the whole root. So I can cancel it out. Finally the resultant value will be A plus B. So A plus B will be the final value of this resultant vector of the two vectors. And what about the angle? So tan beta, which is the angle between the resultant vector and the first A vector. So it will be A vector, B vector and R vector. This will be the angle beta. So if I substitute in the formula B sin theta divided by A plus B cos theta. So instead of theta, if I substitute 0 degree and here 0 degree, this sin theta will become a 0 cos, sin theta will become as 0 and cos 0 will become as 1. However, the entire thing will become as 0. So tan beta is 0, and to find the angle beta is equal to tan inverse of 0, and finally beta will be 0 degree. So these two things are very important. And one more thing, when the two vectors are parallel to each other, a vector and b vector, the final vector, that is the resultant vector, will be the maximum value, so about the next case we'll see in the next